Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Sorry, just give me 1 second. Okay, so starting with question 1. Draw the Lewis structure for methanol, which is H3COH. So first, let's calculate the total valence electrons of the molecule. So there is 1 carbon, which contains 4 valence electrons. There is hydrogens, so 4 hydrogens, each with 1 valence electron. And finally, oxygen, which has 6. So I'm going to draw carbon bonded with the hydrogens and bonded to the oxygen, which has the other hydrogen on its right side. So all of the hydrogens will have single bonds, and the oxygen will contain the 2 lone pairs. So if we count out all of the total valence electrons that I've drawn so far, if we recall that each bond contains 2 bonding electrons, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus the 4, so we have 14 electrons. So based on this structure, predict the hydrogen-carbon-hydrogen bond angle and explain your reasoning. So for the hydrogen-carbon-hydrogen, we have, I highlighted it there. So if we look at the carbon, there are 0 lone pairs, and there are 4 bond groups. So if we use the Vesper theory table, when you have 0 lone pairs and 4 bonded atoms, we have a tetrahedral geometry. So this is tetrahedral. And also using this table, we're going to use it to find the bond angle. So for tetrahedrals, it's 109.5 degrees. So for the second part of the question, we want to predict the hydrogen-oxygen-carbon bond angle? So I'm assuming they mean where oxygen is our central atom. So hydrogen, oxygen, carbon. So if we look at oxygen as our central atom, oxygen has 2 lone pairs and only 2 bond groups, so the carbon and the hydrogen. So again, we can look at our VSEPR table, and you can find it here. So when we have 2 lone pairs and 2 bond groups, we have a bent molecular shape. The electron geometry, however, is also tetrahedral. So its bond angle is still 109.5 degrees. So the junior tutor said that the central carbon atom has 4 bond pairs and no lone pairs for a total of 4 electron groups. Thus, the electron geometry is tetrahedral with bond angles of 109.5 degrees. The central oxygen atom has 2 bond pairs and 2 lone pairs for a total of 4 electron groups. Thus, the electron geometry is tetrahedral as well, with bond angles of 109.5 degrees also. Okay, so this solution is correct.